And last question for the section. First fraction is m minus 2 over 3m plus 9. Multiplied by a second fraction, 2m plus 6 divided by 2m minus 4. Again, multiplying, we can multiply straight across the numerator and denominator, and keep in mind any factors where we can factor those as we multiply. The first fraction, m minus 2, does not factor, but we can leave that in parentheses in case it cancels for our final answer. The second fraction, 2m plus 6, we can factor. Finding a number that divides into 2 and 6, that number would be 2. And dividing each term by 2, 2m divided by 2 will be left with an m, and 6 divided by 2 will be left with 3. So 2m plus 6 factors to 2 times m plus 3. Drawing the fraction line. The denominator, we have 3m plus 9. And again, factoring when possible, 3 and 9, we can divide each of those by 3. Opening parentheses, dividing by 3 will be left with m, and dividing by 3 will be left with 3. So 3m plus 9 factors to 3 times m plus 3. Multiplying the last denominator, or factoring, 2m minus 4. Factoring again, we can take a 2 out of 2 and 4. And dividing by 2, we'll be left with m. And dividing by 2, we'll be left with a negative 2. Once we have everything factored and everything written as a multiplication question, we can start to cancel out or divide out common numbers or factors. For example, if we have 2 and 2, 2 and 2 will divide out or cancel. Any factors in parentheses that we have in common, such as m minus 2 and m minus 2, exactly the same, they'll divide out or cancel. And we also have m plus 3 and m plus 3, both the same, which divide out and cancel. Looking to see what terms are left over, we have a single number 3. Keep in mind this 3 is underneath the fraction or in the denominator. The numerator, everything canceled out or divided out. But if you go back to the numbers we divided, 2 divided by 2, if everything cancels or divides, when you divide out, you'll be left with a 1. So our final answer to the question, after factoring and reducing, is 1/3. Title of the first section today is Dividing by Rational Expressions. In this section, we'll divide rational expressions, which again are fractions with variables. One definition or step for the section is multiply by the reciprocal. In this section, just like other sections, if we're dividing by a fraction, we'll end up multiplying by the reciprocal, which is the same fraction but flipped upside down. First question and first fraction, x minus 1 over x plus 4 divided by second fraction, x plus 3 over x plus 4. Again, when we have two fractions and we're dividing by a fraction, we can rewrite the first fraction as the same, x minus 1 over x plus 4. And looking back at the definition for the section, we'll multiply by the reciprocal. So instead of dividing, we can change that to multiplication. And the reciprocal of the second fraction is the same fraction, but flipped upside down. So x plus 4 will become the numerator, and x plus 3 will go to the bottom and become the denominator. From here, we can multiply like we did in previous sections, straight across. Each term in this case is a binomial, which has a letter and a number with a plus or minus sign. So instead of multiplying, we can rewrite the same expression in parentheses. So we'll have x minus 1 times x plus 4. And the denominator will have x plus 4 times x plus 3. Once we have a single fraction with all the factors in parentheses, to simplify or reduce, we can cross off the common factors. The common factor in this case would be x plus 4 and x plus 4. And x minus 1 and x plus 3 does not cancel, but we can leave that as our answer, x minus 1 in the numerator and x plus 3 in the denominator. The x's again do not cancel, since x minus 1 is different than x plus 3. Second question, and last question for the section. The first fraction we have is 3y plus 12 divided by 5y. And dividing this by a second fraction, y plus 4 over 10y. Again, the first step, we have a fraction divided by a fraction. We can rewrite the question. When rewriting, we want to factor when possible. We have 3y plus 12. If we factor that, we take a 3 out of each. Dividing by 3, we'll be left with y. And 12 dividing by 3, we'll have 4. So 3y plus 12 factors of 3, y plus 4. Divided by, 5y stays the same, as it cannot be factored. Dividing again by a fraction, we can change to multiplication, and we'll end up flipping or taking the reciprocal of the second fraction. So 10y will become the numerator, and y plus 4 will be the denominator. Multiplying, we can multiply the fractions again straight across. Common numbers or coefficients like 3 and 10, we can multiply. 3 times 10 would be 30, and the y we can leave on there. So 3 times 10y would be 30y. And the factor y plus 4 we can leave in parentheses in case this cancels out as a factor at the end. For the denominator, we have 5y times y plus 4. 5y would stay the same. And y plus 4 we can leave in parentheses. From here we have a single fraction that we can reduce to get our final answer. The numbers we can divide, 30 divided by 5 would be 6. The y's will cancel out. The y plus 4's, also the same factor, will cancel out. So the only numbers we have left, 30 divided by 5, which will be our answer of 6. Title of the last section today is more complex rational expressions. In this section, we'll continue to divide rational expressions. We'll have more complex or factoring techniques to simplify the answers. First question and first fraction. X squared plus 6x plus 8 over x squared plus x minus 2 divided by a second fraction, x plus 4 over 2x plus 4. Simplifying from here, again we can rewrite the second fraction using the multiplication of the reciprocal, and keep in mind we can factor each of the terms when possible. Looking at the first term, or first numerator, x squared plus 6x plus 8. If you remember from previous sections, we can factor this. This would factor using the diamond or x method. We'll take the last number 8, put that on top of the x, and the middle number 6 we'll put on the bottom of the x. And again, two numbers that we want to multiply to get 8, and those same two numbers add to get 6. Those numbers would be 4 and 2. 4 times 2 would be 8, and 4 plus 2 would be 6. So rewriting the numerator in factored form, the two numbers 4 and 2 will have x plus 4 and x plus 2. For the denominator of the same fraction, x squared plus x minus 2, again we can factor using the diamond or x method. The last number, negative 2, goes on top of the fraction, and the middle number, if there's no coefficient here, we can add a 1 or a positive 1. Two numbers that multiply to get negative 2, and those same two numbers add to get 1. Those numbers would be 2 and negative 1. 2 times negative 1 would be negative 2, and 2 plus a negative 1, which is the same as 2 minus 1, would be 1. So our two factors using 2 and negative 1, we'll have x plus 2 and x minus 1. The second fraction, again we're dividing by. So using the definition or property, we can multiply by the reciprocal, which will be the same fraction flipped upside down. 2x plus 4 would be the numerator. Keep in mind though we want to factor when possible. 2x plus 4, we can take a 2 out. Dividing by 2, inside parentheses we'll have x, and 4 divided by 2 would be 2. So 2x plus 4 becomes a numerator. In factored form, it's 2 times x plus 2. And the numerator, which again will change to the denominator, stays as x plus 4 as it cannot be cancelled. From here, we can multiply the fractions straight across, or one other step you can do is called cross-canceling. Cross-canceling, instead of reducing or canceling from one fraction, you can reduce and cancel from opposite fractions, as long as one term's in the numerator and one term's in the denominator. For example, x plus 4 in the numerator and x plus 4 in the denominator of fractions. We can cancel these before we multiply, since we have a x plus 4 and a x plus 4 on top and bottom of the fraction. Looking for other factors that we can cross-cancel. If we use a x plus 2 in the denominator of the first fraction and a x plus 2 in the numerator of the second fraction, x plus 2 and x plus 2, we can divide those or cancel those out. Looking at the remaining terms, x plus 2, 2, and x minus 1, these do not cancel. So we can write these as our answer. The 2 coefficient can go in front. X plus 2 we can write after. Divided by x minus 1, which is on the bottom of the fraction or denominator. So our final answer, after reducing or cross-canceling, we'll have 2 times x plus 2 divided by x minus 1. Second question, and last question for the section. The first fraction we have is x squared plus 10x minus 11 divided by x squared plus 12x plus 11. And dividing by a second fraction, or second term, which will be x minus 1. For this problem, we have a fraction divided by a single term. If we wanted to, we can make this second term a fraction by putting a 1 on the bottom. And from here, we can solve like the previous question by factoring first and then multiplying by a reciprocal. Looking at the first term, or numerator, x squared plus 10x minus 11. Again, we can factor this by using the diamond or x method. The negative 11 we'll put on top, and 10 will go on the bottom. Two numbers that multiply to get negative 11 and add to get positive 10. Those numbers will be 11 and negative 1. 11 times negative 1 is negative 11, and 11 plus negative 1, or 11 minus 1, would be 10. So the first factor would be x plus 11 and x minus 1. Factoring the denominator. Again, x squared plus 12x plus 11, the trinomial we can factor with a diamond or x method. Numbers that multiply to get 11 and add to get 12. Those numbers would be 11 and 1. 11 times 1 would be 11, and 11 plus 1 would be 12. So the factors would be x plus 11 and x plus 1. Again, we're dividing by a fraction, so we can change that to multiplication. The reciprocal, flipping the second fraction upside down. This time we cannot factor, but the 1 will go to the numerator, and the x minus 1 will go to the denominator. From here again, you could multiply straight across, or again cross-canceling or reducing. We have a x minus 1 in the top of the first fraction, and a x minus 1 in the bottom of the second fraction. So before we multiply, if you want to, you can cross-cancel or divide those out. Looking for another term that we can cross-cancel. The first fraction, we have x plus 11 over x plus 11. If it's the same fraction again, we can cross them off, as long as one's factor is numerator and one factor is in the denominator. The last terms, 1 and x plus 1, do not cancel. But rewriting our answer, the 1 is the only number left in the numerator, and x plus 1 is the only factor in the denominator. So our final answer is 1 over x plus 1. The first section of notes today is add, subtract, rational expressions. Again, rational expressions are fractions which contain variables. First problem today is 5 over 2m plus 4 over 2m. When adding fractions, the denominator must be the same. In this case, they're both 2m, so our answer will have 2m for the denominator. The numerators, we can add those. 5 plus 4 would be 9. Always check and see if the fraction can be reduced. This one cannot be reduced, so your final answer is 9 over 2n. Last question for the section is 2y plus 1 divided by y minus 1 minus y plus 2 divided by y minus 1. Again, both fractions have the same denominator, y minus 1, so that will stay the same in our answer. For the numerator, we want to combine like terms. We have 2y and y. Keep in mind we're subtracting. It's a good idea to put parentheses around the second fraction. So we have 2y minus 1y, which would just be y. We also have 1 minus 2, which would be negative 1. Again, the minus sign goes to the y and also to the 2. Our answer so far is y minus 1 over y minus 1. Keep in mind if you have the same term on top and bottom, you can actually cancel those or divide those out. And our final answer, if everything gets canceled out, there's always a 1 in front, so your final answer would just be 1. The next section of notes is titled Add, Subtract, with different denominators. First problem is 7 over 3a plus 2 over 5. Again, before we add two fractions, the denominator or bottom number has to be the same. In this case, we'll look at the two numbers, 3 and 5, and we want a common denominator that will be 3 and 5. For example, we can multiply this one by 5 to make this 15, and this one we can multiply by 3 to make that 15. Also, the first fraction has an a, which means the second fraction also needs an a. When we're multiplying by 5, keep in mind you want to multiply the top by 5, and the second fraction will be multiplied by 3a. Rewriting our question, we have 5 times 7, which is 35. 5 times 3 is 15. A comes after it. Plus 2 times 3a would be 6a. And 5 times 3a would be 15a. Again, once you have common denominators, the same numbers on both fractions, you can combine those together. 35 plus 6a. Normally in algebra you'll write the variable first, which would be 6a plus 35. Variables and numbers, again, cannot be combined, they're separated. 15a would stay the same. Always remember to double check, see if you can reduce fractions or factor out fractions. 6 and 35 cannot be factored. 5 goes into 35 and 15, but does not go into 6, so this one cannot be reduced. Final answer would be 6a plus 35 over 15a. Next question, which is the last question for the section. 2 over 5x to the 8th power plus 3 over 3x to the 6th power. Again, before we add fractions together, both denominators must be the same. If we do the coefficients, 5 and 3, our common denominator would be 15. So the 5 will have to multiply by 3, and the 3 will have to multiply by 5. Also, the variables must be the same. If this is x to the 8th, this one's x to the 6th. We can actually change this one into x to the 8th by multiplying by x squared. X to the 6th times x squared would be x to the 8th. And keep in mind, if we're multiplying by 3 for the denominator, 3 gets multiplied in the numerator. 5x squared in the denominator would be 5x squared in the numerator. Rewriting our question, we would have 3 times 2, which would be 6. 3 times 5x to the 8th. 3 times 5 would be 15. X to the 8th would come over. The numerator, 3 times 5 would be 15. X squared would go after it. And 3 times 5 would be 15. X to the 6th times x squared would be x to the 8th. And again, when you have the same denominator twice, you can add those together. Normally, again, the x's go first. So we'll have 15x squared plus 6 and divided by 15x to the 8th. Again, always double check, see if fractions can be reduced. In this case, we have 3 numbers, 15, 6, and 15. Each of those we can divide by 3. 15 divided by 3 would be 5, x squared. 6 divided by 3 would be 2, and 15 divided by 3 would be 5. To factor out x's, each term would have to have an x. There's no x on the 2, so this fraction would stay the same, and our final answer would be 5x squared plus 2 over 5x to the 8th. The last section of notes today is titled Polynomial Denominators. Polynomial, again, would be a variable that has a plus or minus sign after it. Question for this section is 9 over m plus 2 plus 8 over m minus 7. Again, adding fractions, we need the same denominator before we can add these fractions. When you have a polynomial like m plus 2, this cannot be changed to m minus 7, but what we can do is multiply by m minus 7. Same thing if you have m minus 7 over here, m plus 2, we'll have to multiply the other side, so both fractions have the same factors, m minus 7 and m plus 2. Keep in mind you multiply the numerator also on each side by what you're multiplying the denominator by. M minus 7 on top and bottom, and m plus 2 on top and bottom. Solving this one, when we multiply 9 times m minus 7, this will be like distributive property. We'll do 9 times m and 9 times negative 7. 9 times m would be 9m, and 9 times a negative 7 would be negative 63. For the denominator, you can leave it in factored form, which would be m minus 7 and m plus 2. If we add to it the second fraction, again we're multiplying by 8, so this will be distributive property. 8 times m and 8 times 2. 8 times m would be 8m. 8 times 2 would be 16. The denominator also again would stay the same, m minus 7 and m plus 2. Once you have the same denominator, both fractions have the same two factors, we can